Hey, Yushman. Congrats. You were fast. Ba-ba-bum. Hey, Gartham. Hello, hello. How am I doing? I'm doing fine. Thank you. Not bad at all. Not bad at all. So let's put a short countdown for the stream start. Although, you know what? Whatever. I'm going to stream right away. I'm just going to fill my cup of tea, which I have already made. So, yeah. Yeah, I would say we are pretty much good to go. Okay. Um, yeah, let me go get the tea and then I'll start. I got a Mac recently, and I feel drunk using a Mac. It's like a lucid dream whenever I use it compared to an Arch PC. Well, the hardware is nice, generally speaking. Mac OS uh, is it used to be better, I think. Anyway, such is life. I mean, I'm using a Mac myself, so the emoji key. Oh, really? They have it's an emoji key. I think in the new keyboards, I think the keyboard that I have on my uh, MacBook Air M1 doesn't have that, but kind of funny. Still, yeah. Deal breaker, I can't use that. Wow. Okay. So what are we doing today? I'm continuing the work that I've been doing the last few days, which is taking Ziggy and making it better. And so related to that, I have yesterday I ended up with a bug in the LSP which I fixed. It was very silly. So I would say the LSP for now is kind of okay, done, minus the fact that there's definitely a bunch of code paths that I have not tested yet. And by tested, I don't mean, serious testing. I mean, not even tried once to trigger. So we need to at least do a test run. I would say it's the kind of stuff that it's not gonna break easily. So, like, how can I say? Like, unit testing an LSP requires a bunch of strategy, and I don't want to do that now. Honestly, it would require also to put some abstraction layers in the mix, and let's just. I'm happy to just test that it works once, twice, and then have the users take it from there. If you know what I mean, wink, wink. As in they do the testing. but because I'm thinking that it's something where it's not code that I'm gonna touch much. So once we iron out any big kinks that's in there, it's gonna be fine. Hey Johnny, hello, good morning. So so what is it that we have? We have, I was looking at our root.zig. So I'm looking at what it is that we are exposing to Zig users. Yeah, we regressed a bajillion things. So right now we have a tokenizer and AST for schemas, and a tokenizer and AST for Ziggy documents. And then, well, the LSP, the CLI tools, sure. But that's kind of it. Like if you want to, for example, deserialize a Ziggy document into a Zig type, well, we don't have that. I mean, we have the old stuff that's broken now. And that pulls in also, we're finally getting closer to having to decide what to do when it comes to the relationship between schemas and Zig types. And I'm starting to understand, I think, what I want to get out of this system. And it's going to be something that I believe other languages just do not do. So it's going to be fun. Maybe. In the meantime, so yesterday on my own, I have an entry here for cleaning up the project directory. And I was working on it. So yeah, I removed some files. Now I have definitely fewer than I did before. So here we have main, we have root, we have CLI that contains everything related to CLI. We have schema, we have Ziggy that contains everything related to Ziggy. I'm thinking that the stuff related to Ziggy should not be under Ziggy. I think that the stuff related to Ziggy should live in the root directory. So I am going to move these files out a bit at a time, not all at once, because my plan is to nuke the Ziggy subdirectory and then just have everything Ziggy in the top level. Because it's kind of stupid that you do Ziggy /source/Ziggy. I hate that on top of everything. So yeah. So let's do this right away. Move Ziggy /AST to AST.zig. Move the tokenizer to tokenizer.zig. Perfect. Here I'm going to restart the editor so that it doesn't try to save files elsewhere. Hello, Calder. Hello. So root. So schema comes from there. Ziggy comes from the root. Is there anything interesting to say about the tokenizer? Sorry, he can't stream because he's gonna watch me stream. So what do we do? What do we say about this guy? So here's one interesting thing about this tokenizer. It understands the concept of the Ziggy document being delimited by dashes, backticks, or a closing script tag. That is mildly interesting, although you don't care about that way normally. I think it's in init options. Yeah. So nothing interesting about the tokenizer. Tokenizer just, you know what? We put tokenizer down here next to it. There you go. I think this looks good. So down here we have schema. let's add docs for the schema AST. Parses a Ziggy schema into an AST. Can be used to validate Ziggy documents. See AST dot validate for more info. Something like this. Oh, also check it out. I can do reflow on doc comments and it works in Helix now. It used to not work, but now it does. It has worked for a while. I just didn't realize that. Okay. I like you stream too, Loris. Thank you. I was mostly joking. So, okay. So AST tokenizer, delightful AST tokenizer. Okay. Ziggy documents and schemas. Yeah, maximum size of 4 gigabyte. I don't know why this is not std.math.max u32. That's oh, maybe that's why we don't have std in here. I mean, there is no problem in pulling that in, but okay, you know what? I'm gonna leave it as it was before. Fuck it. Okay, so this is fine. We need to re-implement some of this stuff though. Like, oh, you know what? No, there's more that we should put here as documentation. Note that generate messages for your users. Note that a parse tree can an AST. Okay, let's do it like this. An AST can be validated against Ziggy schema. Can be validated against the Ziggy schema if no, if the document you're loading does not have any specific schema. You should still validate it against the default schema. Against the default schema in order to detect duplicate fields. Maybe I should point that out here as well. Okay. Um, okay. So I don't know. I don't know if this is perfect, but I guess it's better than nothing. Um, what do we do next? I think we need to basically resuscitate some of these guys. I'm thinking that a good starting point is the serializer. And stringify, huh? To be honest, do we need anything other than just stringify in here? Turn Zig objects into Zig documents. Yeah, I'm not sure we need anything else. Also, I hate this name stringify. I think I'll rename this stuff just to serialize. We'll see. In any case, std IO writer scope serializer. That makes sense to me. Let's also do this. Actually, we don't need that. Hey Rocco. Hello, hello. Stringify options. That calls stringify inner. Because stringify inner has some recursive stuff going for it. Should our thing be recursive? That is an amazing question. There is not much more that we can do, huh? About that. Yeah, there's really not much that we can do about that. Yeah, I don't think it's worth trying to make it not recursive. So, what does this guy do wrong? You know what we can do? I know what we can see that it's doing wrong for sure. Let's look at options. Does he complain about anything? No, it doesn't have any diagnostics, not anything. You know what? I think this guy is not that bad. I think this guy is doing mostly fine. So, yeah, it looks at types. So, okay, you want to serialize a bool, a float, an int, a comp time, float, a comp time, int. We just print the value. That does imply that we serialize NaN as an NaN, I believe. Also, minus inf plus inf. I think we do serialize those. Those are not supported by JSON, so we're kind of saying that we support those. So we should be careful and like intentional about this. And I have not been intentional about this whatsoever right now. So I don't know. I guess this is like polish for the future. And that's not super important to get right away, but something to keep in mind. So far so good. Pointers. Slice one or yeah. So weirdo pointers we don't support. Slice. If it's a U8, we treat it as a string. Otherwise, we do stringify array. This sounds good to me. Array. If it's an array of U8s, we write it as a string. Otherwise, we write it as an array. Null becomes null. An enum literal. There we go. An enum literal becomes a string. This used to be the case, but this is not like this anymore. So an enum literal is now like this. And we can even make it better, right? We can use T, get rid of tag name. So we can simplify their TOEFL's code. Also, you know what? We can squish them a little bit more. It's fine. Also, these guys that are so simple, I'll put them up here. So array. Enum. Let's see, what does it say? Zig option has decal stringify. Oh, like this is a proper enum. So it could override the behavior. So we call that thing. That's fine. Otherwise, we do this. So let's update this stuff. So this is fine. Oh, I see why enum literal was down there because it's kind of related to enum. But it's not really. I mean, it is an enum, but when it comes to this stuff, not much. Okay, so the option stringify, otherwise stringify struct, union, otherwise stringify union, optional. If there is a value, beautiful, otherwise just null. So that works for me. Escape string. Oh boy, this one will need to change dramatically. Let's keep it for now. Stringify array. Also, you know what? I'm thinking these guys, they need to go vertical as far as I'm concerned. Do stringify array, curly. Let's see. No final comma plus spaces. Minified, blah, blah, blah. Right comma, stringify inner. Indent. Stringify inner, blah, blah, blah. Indent. Right all. So this all doesn't need to change, I think. Omit curly. I think this should be renamed in omit curlies, not curly. I mean, you could say that it's curly braces and then braces is omitted, but then if you do that, you should change this to curlies, I think. So let's do it. Omit curlies. So stringify struct inner, otherwise blah blah. Stringify struct inner, indent, blah blah. Okay. Stringify struct inner. Has fields. Oh, this is the metaprogramming part. Oh man. I think this needs to be exposed to the build script. Oh, you know what? It's either the build script or yeah, no, it's a build script thing, definitely. Okay, blah 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 blah. This is all fine. Okay. This all seems good. This part is going to be slightly different, although not too much. Okay. Search by union. This is going to be different because in the past, unions were only unions of structs. Now we are talking about arbitrary stuff. So this whole logic will need to be changed. Let's see. Active tag. We printed the active tag. Well, this is now with a dot. And we need to understand if this union has a payload or if the active case has a payload or not. So it's basically like this. If and then this was printing a space. So, if t dot value type, I don't know if it's t dot value type, but type info of the union. No, this is the entire union. Why is it t? And I think it should be u. Okay. So no. Active tag. That is an enum. And so if type of at field union comma at, I think this is a, you know what, this is a very roundabout way of no, I think this is actually fine. I want the type of the active field. So if this is void, then we're done. Although it's probably better that we do it the opposite way. If it's not void, then we do stuff, which would basically be this. So we put in here, although will be different. And then there's the final white space stuff. Okay. So if it's different than void, we need to print the parentheses. We need to print the value between parentheses. So type info else value field. Oh, this is wrapping a random Zig value in a struct. That is, well, there is one way of doing it. So, so in this case, we don't switch. We just do, whoops, just do this. And we don't do any of this. Stringify inner. Is there a reason to do options with an underscore anymore? Oh, this is var. Oh, I see why we're doing this. Hey, Blurry Cat. Thank you for the Prime sub. Okay, so I think this is all fine. We're missing only the parentheses. So we print this stuff in parentheses, and then there's spaces if needed. So yeah, it's a union. And then there's test stringify stuff. Oh, is this really it? I expected this to be worse. Okay, escape string is a problem though. We need to deal with that one. Oh, let's see what we're doing here. Oh, escape string is also in charge of deciding multi-line strings or not. That is interesting. So yeah, sure. Blah blah, right line. We're doing FNT string in Zig. Okay, so yeah, okay. Uh, right. Okay. Uh, does this work? No, we'll have tests now that we need to fix. So let's see. Let's scroll through the tests and see if there's anything that needs fixing. So this is all okay. Do. 1, 2, 3. Nested arrays. Okay. Struct. Struct. Struct with array. Nested struct. Sure. Union. There we go. Okay. This is different now. Oh, structs also start with a dot. We forgot, but that is also kind of important. Okay, so this is how it would have to be. Hmm. Man, single space indentation, that is bold. That's a bold statement. Non-struct union. Okay. Oh, this is testing weird contents. This will become foobar. This will become dot foo. Oh shit. Match in your match matches the whole string, not the string in a string. There we go. So that's how it should look like. Simple start plus skip fields. Okay, so let's see how we're doing with these tests. Let's see, stress, stringify. What does it do? Output buffer, writer, allocating, stringify, expect equal strings. That seems good. You know what? We can make this so much better though. So here's how we make this 10 times better. We stringify delightful. We test that it is what we think it is. Or like even before that, let's test that this is valid Ziggy though. So we import from ast.zig and we do const we do ast equals ast dot init. GPA is std testing allocator. Source is out.written, and options can be left alone. We try this, and then we assert that errors are nothing, or we print them. Oh. Try std testing expect equal. 0 ast errors.len. Defer the init std testing allocator. Defer I think like this error.tag. Okay. And you know what? Let's make this AST when we move it out. Okay, it will be a while before we get to a building project, but let's start working on it. Let's start the adventure. Unable to find is not found. Right. Root source files, root has no member name, language server AST. Right. Document 13. Just AST. Okay, so that was nice. Now we need to run tests. That's going to be not as nice. Okay, it is nice because it's not wired in though. There we go. That's more like it. Okay. So we need a null terminated thingy. Well, let's work there so you don't have to do init. Yeah, it would definitely. I don't know where it is there. Like here, there it would definitely work. But I'll tell you one thing. When I wrote this code originally in here, this wasn't even a thing in Zig yet. Like this feature had not been introduced yet in Zig. So I'll say that in my defense. But yeah, totally. Do. Okay. Try st init. Yeah. I don't know though. I don't think I don't know if RLS is the right term for it because RLS some of it is going away, and I don't know if everything was part of this general idea or if there is a better acronym for it. I don't know. Just saying. Anyway, what it is that we have problems with, right? So this is not null terminated, and oh, okay. So here's how it's going to work. First, we test them for equality. Then after we agree that they test for equality, we test them also for validity. But to test them for validity, we need to first disengage them. So like pop this stuff. So const source is going to be out.get or to own slice sentinel. Null terminator, defer, SD testing allocator free source, otherwise it's going to complain. And here we Oh, and then we delay all these AST stuff, put it down here. And here, instead of out written, we use source. To be fair, though, this is Sentinel, so we could actually do this right away, and it wouldn't be a problem. You know what? Yeah, testing allocator free. Yeah, I think it's fine. Because expected output, yeah, I think it will coerce nicely. So we can do this, then this. Okay, let's see how we do. Unable to resolve a compile time. Fuck. Okay, comp time madness. Oof. Strange by union. Okay, so this cannot be done. Not this way. Like, it's more like this, right? This goes on the outside. So we look at all fields. If the field is us, then we don't have to do this if. We can do it differently. We can do if field. I wish I knew what this guy is. Okay, name type, perfect. If field.type is void, then we break. Otherwise, we do this. This is actually pretty good. Although, you know what? It's fine. I'll go for the more nesting approach. I think in this case, it's not a problem. There we go. If it is different than void, then we do this, but then regardless, we break. Nice. Low road GPA. There we go. So now our errors are running and failing. Expected this output, instead found this output. Oh no, this is disgusting. This is absolutely disgusting. So this white space stuff apparently then must only be done. Yeah, when must it be done? Never. Why is this why are we putting a space in here? Why did we never put it? Let's see. Expected this output. The first difference is there. Oh, there's a missing dot. Right, that is on us. We forgot to put the dot in stringify struct. And some of the tests with structs need to be updated. This one needs a dot. This part is fine. This is not fine. Single line is fine. Dot, 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 dot. Dot, dot. Okay, let's see how it goes. Serializer test union failed. Instead found this. First difference is add some curly. Oh, the top level curly in the union test. Oh yeah. Thank you. Yo, we passed all tests. That's it. Haha, that's nice. Quick question. Could you please tell me the main differences between Zig and Rust? Oh, you... Okay, Road GPA. We're at the beginning of our relationship. And the first thing you do, after saying hello, so, well, thank you for the greeting. Hello. But the second thing you do is you lie to me. You start with quick question. And then you ask me, what are the main differences between Zig and Rust? That is not a quick question, my friend. So, so you have to take back one of the two halves of your comment. Basically, it's either not a quick question or you're not asking me the difference between Zig and Rust. Nah, I'm joking mostly. It is, but it is true that it's not a quick question. Let's do it. Let's do it this way. Tell me a little bit about yourself, and then I will give you a quick answer to your question based on your perspective. So to be clear, I'm not asking you to tell me, it's not a dating app, so I'm not asking you your, I don't know, what type of stuff you like to read, what type of movies make you cry. I'm asking, are you studying? Are you working? Are you which languages do you know? What are you interested in? Web dev, embedded? Tell me a little bit more about that, and I'll give you a quick answer that hopefully will highlight the things that I think might be most relevant for you. All right, so this succeeded. So it seems that we got our serializer updated. So here's the question then. Does this guy need to exist in this form? As in, do you need to have access to serializer? I guess you want to have access to these options. I think I want to rename stringify to serialize. I'm gonna do that. I don't like the stringify terminology. I'm sorry, Jason. Okay. I think we should not default to minified. I think we should default to space 4. Because that's what the formatter does. Okay. Okay. Or tab. Let's see. I started to learn Zig 2 years ago, looking for a low-level language, but people say that Zig is not production ready, so I moved to Rust. I studied Rust for 1.5 years, then go for 8 months. The skills are more related to web, but extending my knowledge to lower-level programming. I have 19 years of experience. Okay. Your stream caught my attention and I was wondering what I missed by keeping Zig behind. Okay. So Zig's level of production readiness depends on what you mean by production, because production is a very generic term. It is production ready for certain folks, and it is definitely not production ready for certain other folks. So it depends on in kind of which camp you live. It is, the ecosystem is certainly incomplete. There are big chunks missing that do exist in languages that have, that have existed for longer. There's obviously the question of, whether we'll ever get there, whether the language will get there, whether we will die or not. That is obviously a risk that exists. That said, Zig has been doing really well in terms of growth and adoption. So, I work at the ZSF, so I'm going to say, I don't know, you might want to check my claims against somebody else's opinion, maybe, so that you can get, a second opinion at the very least. That being said, while I guess I do have an interest in this stuff becoming true, I also have a privileged position because I can observe this stuff. It's my job. I look at this stuff 24/7. So I'm not worried at all about the future of Zig. So in my opinion, you should consider Zig as pretty much a language that is getting there. It's not fully there yet, but it's almost inevitable that it will succeed. So then the question is, okay, let's say that you're fine with this. Should you jump in now or wait more? Zig is not 1.0 yet, and it will be a while before it gets to 1.0. So we will keep breaking your code for a while, because not because we enjoy breaking your code, but because you make things and then you find out that there's a better way of doing the same thing, and so you change it, and that breaks people's code because they have to do things differently now. Recently, there have been two big changes because the whole way in which we do I/O has been overhauled, and now there's also the introduction of async I/O, which we used to have, then got removed because it wasn't good enough, and then it took a while for it to come back, and now this new implementation is delightful. So this is pretty much I strongly suspect the final form of this stuff, or modulo minor adjustments. This is going to be the real thing. And so there's that. So then the question is, okay, let's say that you are you're optimistic as I am about the future of Zig, and you are fine with us occasionally breaking your code, but not horribly, you will have to do some work to update from one version of Zig to the next, but not a huge amount usually. And also usually those updates, they will be welcome. Like you should expect the things that change to change for the better, not for the worse, for sure. Then the next point is, not horribly Writergate, IOgate. Yeah, I know, but well, this storm has passed, so I don't expect things to be this cataclysmic going forward, and they're not that cataclysmic. They're serious ones, yeah, but also this is another example of things improving for the better. I think the new I/O stuff is much better behavior wise. Maybe syntax wise is a bit cumbersome compared to what we could do in the past, but that's the price of switching from generic writers to runtime polymorphism. In any case, to conclude, to get towards the conclusion. So the question is, can you make do with the ecosystem not being perfect? I'll give you one example. We have a language server. It's called ZLS. It can give you support when writing code. You can see me use ZLS also here as I'm editing, but it is not perfect. We don't have this fully implemented. It will, but it's not there yet. So if you can make do with a slightly imperfect tool chain with the optimism that we will get there, just not now, then I would say the final differentiator between us and Rust is that Rust is a language that makes heavy use of abstraction, and you get mileage, you get value out of those abstractions in Rust, but they are abstractions. So if you're somebody who really enjoys making abstractions and dealing with other people's abstractions and being gated off the ability to do certain things, that's the cost. But the good news is that, you don't risk doing things wrong and not realizing that as much. You can still do that, obviously, like in every programming language, but not as much, because the compiler will put a bunch of safety handrails around everything that you do. Then Rust is your language. If instead you find abstractions annoying and you like code that is explicit and you like the ability to reason locally about things, as in you read a piece of code, like here in Zig, I read a piece of code and I don't know, this is not doing much, but I read this piece of code and I know that every time there's a multiplication, it's a literal multiplication. There's no operator overloading. If I see access to a variable or like to the field of a struct, I know that's what it is, because you can't do, like, there's no getter setters, like weirdo stuff going on. If it's not a function call, if it doesn't look like a function call, it's not a function call. That's the idea. And in general, the idea that code is not overly abstracted and that you can, as I said, you can do local reasoning, then you might appreciate Zig. I would say that if you like you did Go for 8 months. If you hated Go, I mean, Go is not the greatest language in generally speaking, but Go also has an appreciation for simplicity, although not the same exact kind that Zig has. There's like big differences once you get down to the details. But if you felt like Rust was too overly complicated, then I don't know, then you might like Zig. If you want more precise information, then ask more precise questions. I'll be happy to answer them. I've been enjoying the new async, but I had a question. I'm from a JavaScript background, and it seems like group is similar to promise all. However, I can't make it work with options. Am I missing something? What is options? I can't make it work with options. What's an option? Group is similar to promise all. Yes, in some ways it is similar to promise all. I believe that promise all... Well, so if you want to get down to the details, promise all takes in a list of futures. And with group, you don't get to access the features at all. So there's a difference. But, setting aside these minor details, if you tell me what you mean, I can make it work with options, I'll be able to help you. If you want to do some even better help, when a function returns an optional result like... no, right. Oh. Okay, what you're describing as an optional result... so in Zig, optionals are the things that can be either a value or null. This, which is a specific type of union, right? It's an union between something and null. While this is a union between error codes and in this case void. So I would call this is generally described as a error union. Okay, so you have a function that returns an error union. The answer is that you cannot mix group and error unions because the future is lost. The future of any specific invocation is lost. So you have to handle these errors in a different manner. Not through return values, because think of it this way. You're kind of tossing away the quote-unquote individual return values of each function. You're tossing those things away. So it's kind of by design that it doesn't work. If you want an alternative, here's what you can do. Instead of doing group, you know how you can do promise.all, but keep also the futures. You do something like this, like var futures is std array list of future, and well, I think that's std.io.future, and here you need the type of future, which depends on the return value. And this that you gave me, it's an underspecified return value. This is not explicitly saying what the error union here can be. So you cannot say, my point is that you cannot do this. You cannot say this is the union or just an error and void. It doesn't work. So you either know what the error is, the error set is explicitly. So like error, for example, I don't know, out of memory, file not found, right? Either you know the error specifically, which sometimes you can also get from definitions in the standard library. So for example, writer has its own error set defined in the standard library. So you can find all these definitions if you search for them. And like you can resolve, my point is that you can resolve the error set of any function that has an implicit error set. Alternatively, if you can't, because maybe the functions that you pass, maybe these functions have like different error sets each, you can do this. You can do any error. That's type erasure of the error set. I would say this should be your last resort, like your really last resort. Do not do type erasure of error sets unless you really cannot do it any other way. Okay, so you let's say then your things have error out of memory, uppercase M. So you do this, and then you do for or I don't know how many calls you have of these things, but like you do basically you do I'm going to use pseudo Zig syntax now. I'm not going to be super precise, but you will get the idea. So you do try append futures dot append io.async foo1, right? And you get the idea. You call foo1, foo2, foo3, and then you do for futures dot items f.await. Well, try f.await. Something like this. So this way you can do it because you keep the futures around, and then if you think about it, this is future.all kinda. But my recommendation would be my first recommendation would be change the return type, handle errors inside the function, don't bubble them up if you can. If you can't, then it's a question of whether the control flow that you're using makes sense or not. Let's see. I really appreciate the time you put to answer the question. You're welcome. I paid attention from the beginning to the end. Well, thanks. Answer my question. Okay, awesome. Well, okay, what was I doing? I succeeded at fixing serialize, right? So we're happy about it. In root, now we have serializer, we have stringify, but stringify doesn't exist anymore. We called it serialize. No problem. Hello from your favorite interdimensional being. That is a strong statement. What have you done for me from the other dimensions to make you my favorite interdimensional being? Because last I checked, I haven't gotten shit from the other dimensions. Huh? Turn Zig objects into Zig documents. Okay, so this is fine. It's a bit, okay, it's annoying that serializer and serialize look very similar. Let's do it like this. Turn Zig object into Zig documents. Name space contain definitions for serializing Zig values to, well, Zig values to Ziggy documents. I don't think we need to say anything more than this. Namespace contain definitions for serializing Zig values, Ziggy documents. Okay. And then I would say that the opposite, instead of being a thing called parser, it should be deserializer. If the process of turning a value into a document is serialization, then we can do deserialization. So then the inverse should be deserialization, without a doubt. It's not a delightful name, but it is a precise one, and it helps avoiding confusion. The whole system was very confusing for no good reason. So instead of parse leaky, let's change this to deserialize. Yeah, Marshall and Marshall also is nice. I agree. I agree. Marshall and Marshall. But I don't know. I think I'm fine with the more vanilla names. So what is Zig in short? Hello, Code for Freedom. What is Zig in short? Zig is a general purpose programming language for maintaining robust, optimal, and reusable code. That's what we have on the website. It's a lower level programming language, slightly less in short. It's a lower level programming language. It basically is considered kind of a spiritual successor to C in a way that not even C++ ever was. Some people have made cool stuff with it. One is Ghosty that you see me using now. It's a terminal emulator by Michio Hashimoto. There's a database called Tiger Beetle. There's a JavaScript runtime called Bun. I say JavaScript runtime, that's not very precise. I'll call it a JavaScript toolchain because it's a few different things in the JavaScript ecosystem all at once. So it's a JavaScript toolchain. What else has been made with Zig that is relevant? I don't know. There's more projects, maybe not as prominent as the ones that I just mentioned. I made a static site generator with it. There's River, which is a Wayland compositor that I think a few people like. There's a handful of games on Steam made with Zig. Maybe handful is a strong word, but the port of Baba Is You for the Switch was not written in Zig, but it was compiled using the Zig toolchain. So that happened. Then there's a couple games written in Zig on Steam. One is something Pirate Strategies, I think, and another one is oh fuck, I'm forgetting the name. Fuck, the game from Madrigal Games. Why am I forgetting the name? Traction Point. There we go. Traction Point is a game about cars. That's all I know about it. I'm new to Zig, coming from JavaScript and Rust. I build blockchain applications and was convinced to try Zig after a friend's recommendation. What is the best way to learn? I'm currently reading Pedro Duarte Feria's Introduction to Zig. So yeah, that's a book made by a community member. It's fine. Actually, let me double check that we're really talking about the same book, because that's Pedro Pac, right? Pedro Duarte's is Pedro Pac. I think I know the nickname better than the full name. Pedro Park. Yeah. Okay, perfect. So yeah, that works. That's fine. My recommendation is go to zigline.org. There's a learn section, and there's a bunch of online learning resources. I would say read the language reference. That should be your starting point. So no matter who you are, what is your whatever is your situation in life, step number 0 of getting started with Zig is read the language reference. Then everything else can change depending on your life situation. But that is step 0. It's the same for everybody. Online learning resources. So the book is mentioned here. There's also Zig Guide, Zig links, exercism. There's also a series of blog posts. And then find a project that you find interesting and start with something that is not too ambitious, but then try to venture out in doing things that you've never done before. So for example, don't do webby shit. Try to do something like audio processing, for example, like something that is where you can really where you need a lower level programming language to really pull off, and do something like that. There's also already packaged solutions like not solutions, but like already packaged like experiences, like ray tracer in a weekend. You can do that in Zig. Zig is the right kind of programming language for that type of stuff. And you probably never written a ray tracer before. I did that a while ago. And so the book will give you examples in like example code in C++. It's going to be your job to translate it to Zig, but you can do it. And you can also find people that have done that before you in case you get stuck. I'm one of those, but definitely not the only one. And then you can also do other stuff. There's a book called Operating System in 1,000 Lines of Code. And it really takes 1,000 lines of code, actually less in Zig, to get a bare bones operating system with user land and like user space and kernel space to get that going. I did that also. It's on my GitHub, and yeah, have a good time. And then interact with the community. Ask people for help when you get stuck. Have a nice day. Okay. So let's do this. Pub const deserializer. No problem. How do you use SCD client fetch and get responsive buffer in Zig 0.15.2? Oof. That is indeed a good question. And you're hitting a weak spot because I haven't used the HTTP client in 0.15.2. And here's the problem. I used it before, and I'm Well, I haven't really used it after, but I can show you how to use it now in 0.16 dev. And I think that 0.15.2 is kind of a in weird intermediate situation. And also be careful because I think that there might be some bugs in 0.15.2 in the HTTP client. The reason for this is because the whole IO system has been overhauled, and the release had to come out because we kind of need to be more or less in lockstep with LLVM releases so that distro maintainers can update Zig. Well, basically, when distro maintainers want to update LLVM, then they need to update everything that depends on LLVM, and so that kind of makes their life easier, I guess. But that means that the release had to happen also with some outstanding bugs. So my point is, I don't know. If it's all the same for you, I would consider switching from 0.15.2 to an unstable build of Zig. If you have Zig up, you just do Zig up master and you get a new version. Right now I have 0.16, 1.2.3.6. This means that it's 1,236 commits past the last release. In any case, with that being said, your question still stands, though. Let's take a look. So what does fetch look like? So performing one-shot HTTP request with the provided options, this function is thread safe. There's a client, there's fetch options, and there's a fetch result. So client is an HTTP client that I guess you have to create, and you have to instantiate. You have to initialize. Init default proxies populates HTTP proxy based on the proxy environment variables. Oh, interesting. So this. So it's init default proxies the only constructor for a client. By the way, I'm learning myself as I read this stuff. This is interesting. So that's a connection pool. Response request. Yeah. Refreshing from mvar. Okay, so I guess this is, so you create an HTTP client this way. Well, I mean, I guess the idea is that well, let's see what this does. Also, notice that it wants a client pointer. So, Brian, I don't know how familiar you are with Zig, so maybe you can give me a hint in case that I'm missing the mark. But in case you don't know, you can do, when you have an init function that looks like this, that has the signature that doesn't give you a client, what you have to do is that you have to make an undefined client. So you do var c HTTP, well, client, so sed HTTP client, and then you set it to undefined, and then you do try c.init. Init default proxies. And then you pass in an allocator, the allocator that it wants you to give it. So you do this. And that way, now you have an client that has been initialized. Okay, so this is the first part. Then, once you have a client, then you can do fetch on it. Fetch options. Null means they will be heap allocated. Null means they will be heap allocated, compressed buffer. Redirect behavior. If the server sends a body, it will be written here. Response writer. Standard headers that have default but overridable behavior, extra headers. So it seems that when you want to send a request, you have to fill out this options thing. And my guess is that you want to set response writer, and you will want to pass in an allocating writer, so that basically you end up heap allocating the response. Let's see, fetch result. What does it give you? Oh, just a status code. Okay. So you see, basically here in the request options, you specify how you want to receive the body. I guess you can pass null. And when you pass null, the idea is that the body should be discarded. And so the client will just discard the body, because maybe you're making a request where you don't expect a body, so you don't care about the body. An example would be maybe you're doing like a what's called head request, where you only care about headers that tell you when a given file was modified last, etc. And so no body is needed, and so yeah, you can pass null. So I guess the final piece is, how do you get an allocating writer going? And it looks something like this. You do const, I'm going to call it AW, allocating writer. And it's going to be an IO, well, std.io.writer.allocating. You need to init it. And it wants an allocator. And then you can do, sorry, this needs to be var, because it has internal state that needs to mutate. And then you do const writer or W, whatever you want to call it, is going to be, I think it's aw.interface. No, I think it's aw.writer. Ampersand. So you pluck a pointer. You pluck a point. Keep in mind, this is an writer implementation. This is a interface. So you pluck the interface from the implementation, and that's what you pass around. This is what you set. Then after you're done, here also defer aw.theinit, for example. And let me double check that allocating had, yeah, it's writer. There we go. So defer the init, and then oh, you know what? I'm gonna put this in a scope so that Zig doesn't stop complaining about it. Then if you need to access the result, in let's say in this same context, you can just do aw.written, and it gives you the slice of written bytes. And if you want to extract the written stuff from the body, maybe even giving it a null terminator, it's kind of like an array list. So you can do aw.toOwned slice or owned slice sentinel, and then you can say that you want a null terminator, for example. This needs to be tried, because this resizes the allocation, and that gives you the I don't know, body bytes. This gives you the body bytes, and now the allocating writer is empty after you call this one. And this is going to be a heap allocated string, so eventually you will have to do something like gpa.free body bytes. There you go. I think with this, you know the full story. There might be some minor differences in 0.15.2, but this is the general gist. Okay, so this serializer is what we were previously calling a parser. Maybe you know what? I'm going to copy everything over, and then we see how we go. Oh, maybe we should give it a uppercase name. Okay, we'll see. GPA code parse options tokenizer state closed front matter. Hmm. I think there are 2 points, right? One is we might try to deserialize from a string directly into a type. And then the second one is we might be trying to do that from an AST. And those will have to work differently. Yeah, this would have to work differently, although I think it's not really necessary. Yeah. Okay. There's a bunch of state in here that we need to worry about. Parse options. Front matter error. Container. State. Add error. Like seams. Parse leaking. So one thing that made this thing more complicated was the need for error reporting. And I remember being very unsatisfied with the error reporting here. And I remember also thinking that it was kind of not possible to really provide good error messages because we would be conflating correct syntax in the Zig document versus compliance with the expected type. So here's what I'm thinking. I'm thinking that this code maybe should not even attempt to report error messages, like comprehensible, like good error messages, because I don't think it even can. Let's see, in 0.15.2, writer interface can be passed around and the buffer can be used to read the data. I'm guessing this is related to this discussion. I don't know. I mean, if Brian, if you're still around and you end up having trouble, I don't know. You can copy paste whatever error message you get, and I'll help you decipher it in case that it's confusing. Okay. Yeah, I don't really like this old approach. Like, not at all. I'm kind of tempted to start from scratch. Let's start from scratch, and then we can move over. We still have the old file, so we can move over stuff in case it's needed. So let's do this. Why Bork is not showing message timings for the last messages? Because I never implemented this for messages coming from YouTube. It's on me, entirely on me. That's all. But you know what's funny? It's also what tells me that the message is coming from YouTube. Okay, deserializer. Can't you just take local time? I could. I think maybe. I don't remember. But it's definitely easy to do. I just was lazy. Like regardless, even parsing the stuff from the message, totally doable. It's just a piece of missing feature. But we'll get to it. It's on my to-do list, async Borg. So we're gonna work on this. Okay, so deserializer. So I guess we need to have a public function deserialize, right? Where in deserialize, we take a document and we turn it into a type. So it's like you pass me the type, and I do that. Also, you know what? This is interesting because um this is the function. This is the space where we might start worrying about different usage patterns. So I'll explain that in a second. But the idea is we're gonna have t type, and then you give me, I don't know, source. Well, you give me an allocator, and then source, and I give you a t if everything goes well, right? So this is one signature. That's one way of doing it. But check this out. Here's another way of doing it. Let's call it update. And instead of giving me a type t, you give me a value. You give me GPA. You give me source. And I give you an error or void. So here's how it works. Value needs to be, or you know what? Let's do it like this. T type. And value is a pointer to t. And we return void. So the idea is that update takes in a pre-existing instance of this value and just updates it with the contents of the Ziggy document. The reason why this is interesting is because this second pattern allows you to say, it allows you to stack multiple documents on top of another, conceptually speaking. It's the thing where you can have system-wide configuration and then user-specific configuration. And so what you do is that you first load the system-wide configuration, and then you load the user configuration last, and you allow the user configuration to override anything that to override some fields and leave everything else as it was. This also allows you to have in-program defaults if you want. I think this is an interesting usage pattern. Obviously, an alternative would be to have something like this: deserialize stacked, where sources source list is a slice of these things. So you give me many Ziggy documents and they get applied in order. So it's kind of basically this doubles as both, basically. Maybe with some advantages, maybe not. I don't know. Maybe you could argue that this is more flexible. Maybe. That's I mean, this requires you to have these on hand. This does not. But is there anything that you can but there might be something for you to gain by being able to observe all these guys all at once. or maybe more than update, it should be like merge. But here's the thing. Then we would have to define what the merge semantics are, and I don't know about that. So in any case, this is interesting. Let's do normal deserialize first, and then in the future we can worry about the rest. So I think this should be like this. So it can be out of memory or syntax or mismatch, I guess. But then there would be, I think we need options. So options. What type of options do you pass in for this stuff? Maybe you can optionally select a schema. Yeah, maybe it could be on optional schema. Also, you know what this makes me think? That in root, instead of this, we should have these. We should have these. Yeah. Okay. To random question, I wanted to put some of the audio decoders I wrote into a module in a separate repository. I wanted to get ZLS completions when developing, but given it is just a library and not an executable, the check step, if provided, this module does not do anything since no symbols are needed. Is there anything I can do to get a full LSP for modules? Yes. Do you have tests? If you have tests, you can have your test executable be the thing. Then basically, here's like a trick to make this work in a quick and dirty manner. Make your check test an alias for Zig build test. That's it. So basically, ZLS will run your tests on build, and that's actually, assuming that they're not, like humongous that take forever to run. It's actually nice because then one funny side effect is that you will get in your editor squigglies on the line where your tests fail. You also get that. So solves your problem. It also has a funny side effect that it's, I don't know. For me, it's welcome. But your goal is that, as you pointed out, right? It's just a module, so it's all stuff that is not used. So it needs to be used somehow, and your tests are an executable that uses your logic. So yep, they can act as a substitute. This is checking against the schema though. You know what? It's not really it. No. I take it back. Do. Side note, Og Vorbis spec is a giant pain in the ass. I have no experience with it. Fortunately, question mark. But I can imagine. I've only tackled simpler specs, I think, up until now. And some of them can already be very annoying. So I can imagine. Yeah. Okay, so here's one thing. So here's the one problem, though. We need to complain about syntax errors. When I'm reporting D2 to Vorbis, I think a nicer question is when am I porting D2 to async IO? This is coming, by the way. I'm not doing this right away, but D2, I haven't touched it in a while, but I'm going back to it without a doubt. And I think my goal is to get off Discord by the end of 2026. And hopefully it would be nice to have a work, a D2 that's working well enough so that we can genuinely jettison. And then go where? What do you mean go where? Go to D2. So maybe Diablo doesn't know. So Diablo D2 is the semi joke name. It's Discord 2. It's the semi joke name of my Discord replacement. So I'm making a chat application, kind of like Discord, but where servers are self-hosted in Zig. I got it working up to the point where I can make calls. Like we had a ZSF meeting on D2 one time, and it works. But the problem is that we had old IO, and I was using libxcv, and I stumbled upon a very annoying UDP bug, and in any case, so now that new IO is a thing, I will basically rip out libxcv, port everything to native async IO, and also use that to influence the design of IO in case that we discover something interesting about that. It's what human made slop of npm. So in my case, here's how I want to make D2 work. By the way, the name D2 is temporary. The joke is that it's Discord too, but it's temporary, and it's not necessarily meant to be a one-to-one to Discord. Although I guess the null hypothesis is something that kind of looks like Discord. So self-hosted servers. Then the idea is to have voice channels like Discord, or before Discord like TeamSpeak. So the idea that you have like these open voice channels where you can see who's in the channel, 100% want to have that. Then the idea is also the idea is for it to be not necessarily a generic chat application tool, but I want to design it basically for open source communities. Like the idea is that you have an open source community, like you're working on some open source project and you want to collaborate with people. The idea is to make sure that works well above all else. Zulip voice chat module? Fuck. No. No. Or rather, I don't know. If you mean like we implement this and then somehow integrate it with Zulip, I don't want to do it, but that's fine. But sorry, my reaction was because Zulip, at least the way I experience it, is that Zulip puts you in a Jitsi call. Zulip voice is super bad because there is no Zulip voice, at least as far as I know. In the ZSF server, when we press the button for a call, it sends us to Jitsi, and Jitsi is S. It's complete and absolute S. Oh, also this. One reason why I hate Jitsi is that it's peer-to-peer. Jitsi is peer-to-peer and it keeps falling apart. I know peer-to-peer. D2 is designed to have communication go through the server. So we'll see. You don't have to do this. I mean, the Zulip is open source, and I have a Zulip client on my phone, and it works. I'm surprised you own a Mac. I have all three systems. I have a Windows machine. That's where OBS is running. I use it. I have a Mac. I use it. Like, you see me using a Mac because that's what I'm screen sharing. But my personal computer is a Windows machine. I don't love it. I can tell you that much. But I use it, and I also use Linux. I don't know. I have no loyalty. I jump across all of them all the time, and they all suck in their own special way. To be honest, all of them have their own special way of sucking. Which, I guess, you know what, said in a more positive manner, each one of them has that special something that none of the others have. On Windows, that would be ads in the start menu. All the real hardcore open source people. Is D2 open source? Not yet. It's a private project because it's so incomplete and like janky, and it's super in progress. But it's 100% planned to be open source. Actually, it's the one project where I would consider a non-MIT license, and I might want to go for a more aggressive copyleft license. So I'm thinking of making D2 something like EUPL. I'm not going to use the MPL. Fuck Mozilla. Definitely not going to use anything GPL. But I'm fine. I think it's not a bad idea to make D2 more copyleft. And so, as a proud European, I might go with the EUPL. We'll see, though. And actually, by the way, this Ziggy work that I'm doing right now hopefully can also play into D2, and this can become a configuration language to do. AGPL. Yeah, I think that, you know what, maybe I should read more into it. Maybe AGPL. Yeah, maybe. I don't know. In any case, I'm thinking for the 42 a copyleft license is the right one. I never do that. By the way, you mentioned that I'm an hardcore open source guy. I don't know how to describe myself in that sense. I am. One reason why I wouldn't want to describe myself as a hardcore open source guy is because, you know, the whole open source being controlled by big tech. So to me, open source doesn't mean what they want you to say, but what they want you to think it means. So that's why we say software you can love in this community, and we don't say open source. But your general point stands. That said, I'm generally in favor of doing MIT and not copyleft for most things. That said, yeah, D2, it's kind of a special case. Do-do-do. So error reporting, yeah, for this guy. You know what? Let's leave these empty for now. I think that we're definitely gonna need options, so I'm just gonna leave it there. But so deserialize. What does deserializing look like? It looks like we need to basically make a T. We need to return that T. And I think this idea of deserialize inner is not a bad idea, but the thing is, well, why does it not? Why should it not be deserialized? Oh, I know why. Because we need some kind of offset and we need a tokenizer. So we need something like this, I think. Var T tokenizer equals blah blah blah. Um, so we make a tokenizer, then we do at some point we call the serialize inner with T GPA source options and the tokenizer. And we try this. And we expect this to give us a, well, we can just return it, I guess. Okay, something like this. We might need to make it accept the first token, I guess. But whatever. Okay, in any case, at some point we switch on the type. And there's going to be a variety of options, which I guess this needs to mirror what we do in the serializer. So I really think we can kind of do something like this. Type info of T. If it's a bool, a float, any intercomplete float, blah, 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 write a print. Okay, now in our case, this is going to look different. But it should be like this, right? So we do T.next. Or do we expect to be given, you know what? Let's accept the first token. Because I think it's going to be necessary. So we have a first token. And then we do, so if it's Boolean, we do if first, we switch first token. So here's the problem. Oh man, this is such a beautiful microcosmos. The problem here is, okay, we're expecting to find a Boolean value because we want to deserialize a Boolean. And if we find a true or a false token, delightful. But if we find something different, then here I'm writing mismatch, but actually we don't really know that. We know that this is an unexpected token given what we want, but we don't know here if this is like, well, this code here doesn't know if this is actually a type mismatch or if it's a syntax error. So what we can do is look at all possible tokens that might hint at a type. The problem is that then we would not know for sure. This sucks. This sucks. This really sucks because we really don't know if the syntax is correct or not. This is kind of making me want to go through an AST no matter what. This is making me want to build an AST every single time and then make this work not off of a what's it called, of a stream of tokens basically, but make it work off of an AST. That said, it is true that there are cases where we just don't want to do any of that. We just want to straight up do the most straightforward path from one thing to the other, and that would be skipping an AST. Another approach would be we do not do an AST, but then we only do the AST in case of a mismatch. So here we found an error, and then here we say, okay, now here we build the AST since we did find an error, and we use that to report if there is a syntax error or not, but based on what? So if we build an AST, we know if here there is a syntax error or not. Man, error reporting in this case is, I remember it being annoying, and I remember not knowing what to do. Now I'm in a much better position to understand what the next step is, and it's still not immediately obvious. Because so let's imagine that we make the AST and we get errors, right? So at some point we have const I don't know, AST equals something something, and so then we can reason about AST on errors. But what do we reason about? I guess we can check if any error range covers where we are. In which case we say that it's a syntax error. Otherwise, what? So I think that the idea of making the AST, building the AST only in the error case is not a bad idea. I think that is a good idea. That is definitely a good idea. Hmm. The serializer is expecting a list of acceptable data types and is getting something other than the expected list. It cannot be classified as syntax error. That is wrong, unfortunately. It could very well be a syntax error. I'll give you one example. The tokenizer gives us a comma, or like a curly brace, because it's literally, imagine that the document is this. Um, let's say there is a struct. So there's a struct, and there's a field, and we expect this to be true or false, right? So we like here we are deep. We at the a level above, we were deserializing a struct. Then we got into a recursive call that wants us to deserialize a boolean now, and we are here. We find it true, and it's awesome. We find 10, and yes, that is not a syntax error. 10 would be a unexpected data type. But what if it's this? This is 100% a syntax error, and we don't know about it at this moment. So, yeah. And here's the thing. Then you could say, well, then, but you know then which tokens will correspond to a valid type and which will not, right? And the answer is yes, I can. For example, if we see a square bracket, if after we are at foo, we see a square bracket. Sorry, let's do it like this. We see a square bracket, and we know that it's the beginning of a list. And then in this case, yes, it happens to be that this is correct. This is a field that instead of being a boolean, you know what? Let's do it like this. True. This is now a list of booleans, and we got it slightly wrong. But what if it's actually like this? Like this is another syntax error, but this token is correct. So this token points, this is the first token of a potentially valid value, but until you parse the rest, you don't know if this is correct or not. So where is foo true caught? Level above? No, well, no. If it's okay, given what I have written now, this would not be caught here. Here we would deserialize correctly a boolean, and then we would want to close the struct. So the level, so there would be another call, another recursive call, which is one layer above to this same function. And we would have like the struct handling case, and the struct handling case would expect us to find either a comma or a closing curly. So either a comma and then another field, or a closing curly, and then we see the second true. And that would be a syntax error. So it would get caught. It's just that we cannot say here trivially that what we got in front of us is a value mismatch or a syntax error. There are some cases where it's obvious, but there are some cases where it's not obvious. We don't know what's going on. We don't know what's next in the string. So if we I think these are reporting should work like this. Okay, I think I'm starting to get an idea of how I want this to work. So instead of syntax and mismatch, we really don't really know what's going on there, I think. Or maybe we do. Okay, so here's how I think it should be. In options, you can say whether you want diagnostics. Hey, Dimo Roy. Oh, holy shit. Thank you for the raid. Hello, everybody. Hello, all 87 people. Welcome. Okay, maybe some of you have seen me grapple with HTML in doing very boring HTML work. That is done. That is behind us. We are done with very boring HTML work. We are now doing very boring JSON replacement language work. Okay, I'm assuming that most people in chat don't know about my JSON replacement language, so let me pitch it for you. And to be clear, I understand that you do not want my JSON replacement language. I get it. I'm doing it anyway. I'm doing it for myself. It's not complete yet, but once it will be complete, maybe some people will be interested. I don't know. At the very least, I will be happy. So here's the pitch. And well, okay. So here's the pitch. Okay, I'm changing the syntax a little bit, so the website has not been updated yet, but here's the idea. I've had to deal with annoying RESTful APIs all my life, and they all suck. Well, not all of them, but plenty of them suck. And I think that a good reason why they suck is because JSON is not the greatest language ever, and more importantly, the tooling around JSON is in a abysmal state. So in reality, most of my language is, most of what it's doing is just trying to make sure that there is a decent ecosystem, decent tooling ecosystem around the core language. So here's the idea. First of all, I'm also changing maps to dictionaries. So first of all, I'm making a distinction in, so the language is called Ziggy. It steals syntax ideas from the Zig programming language, hence why it's called Ziggy. First thing that I did was make a distinction between dictionaries and structs. The idea being that sometimes in JSON documents, at some levels, the fields have a expected schema, while some other levels, the keys are completely up to the user. In JSON, you don't see any difference. They all look the same notation for everything. But in Ziggy, I want to show this visually. Like you open a Ziggy document, and you should be able to immediately see what it is that is a key value mapping where the keys are part of a schema, and key value mappings where the keys are completely up to you. So for example, this is package.json. You might be familiar with this. But you know that for package.json to work, you need to call these things dependencies. Like if this field is not called dependencies, then npm will not install your dependencies. Name is important, version is important, right? These things these names are part of a schema. But inside dependencies, this is another key value mapping, but here key names are completely up to you, or rather, maybe not entirely up to you because they have to match existing packages in npm or whatever index you're using. But they're not part of the schema of this configuration for language. So if we look at a hypothetical Ziggy version, you see that at the top level, we use a struct key value mapping syntax. And inside of dependencies, we keep using the other syntax, which is what I used to call maps. I'm renaming now to dictionaries. So you immediately, as a user, open this document for the first time, you immediately know, okay, so dependencies has a meaning, and in this one, the keys don't really have a meaning. And so you know that you can do go to definition on dependencies and expect some kind of definition to be somewhere. But you know that you shouldn't expect that to also be true for React or LeftPad. Related to this, there's also tooling that does exist, which I have implemented, where, let me see if I can do it in a nice manner. Test Ziggy schema. Okay, so this is a Ziggy schema. I haven't shown this to you yet, but there's a schema language for my JSON replacement language. But if you open test.ziggy, first of all, we have a nice thing that tells us when there's a schema mismatch in the editor, which is nice, but which you can get also from JSON schema for sure. But here on bar, for example, also there's another piece of functionality that I haven't shown you yet. In any case, I have auto formatting, of course. But if I do space K on bar, I get the documentation from bar, which is this one, bar. And I also can do go to definition on it, and it works. So like this tooling part, I kind of, it's mostly there. Another thing that I wanted to show you is this. Basically, if your top level element in a Ziggy document is a struct, so only a struct, doesn't work for any other type, doesn't work for lists, doesn't work for dictionaries, only works for structs. If it's a struct, you can omit the outer level curlies and reclaim one indentation level. So this is a Ziggy document where the top level is a struct, but the curlies can be omitted. And this makes it a decent language, for example, for making front matters. The original reason why I made this language is because I needed a front matter language for my static site generator. I didn't want JSON, I didn't want TOML, I didn't want YAML. I looked at also all of the alternatives. I didn't like any of them, and so that's why I ended up making my own. So you have this. Also, check out what you can do. You can also, since these two syntaxes are kind of the same thing, but they're meant to convey different meanings, there's also like an easy way of switching from one another in your tooling, in your editor tooling. So here, I take out the dot. Structs in Ziggy start with a dot curly when you open it, same as Zig. Which also helps you immediately distinguish between, at the parser level, between what in front of you is going to be a struct versus what in front of you is going to be a dictionary. Because if you only say curly, then you don't know, you need to do look ahead, and it gets ugly. But here's the thing, I don't know if you noticed the blue stuff. Wrong field style, use FMT to correct automatically. So if you remove the dot and you save, the auto formatter will automatically change the key value mapping style. It will move you from the struct style to the dictionary style. And of course, vice versa, you put a dot and it works. The reason, by the way, while this thing was marked as an error is because it doesn't match the schema. The schema says, wait, I expected a full struct and you gave me a dictionary. This is the sigil, the symbol that we use for indicating dictionaries. Okay, so this is some of the stuff that I have going on. We have also the thing where training commas ask vertical alignment, removing training commas. So we support training commas, by the way. Taking out the training comma means horizontal alignment. So you can have play, you can negotiate with the auto formatter. Sorry. More interesting stuff. So, well, let me show you also here inner, right? This one is a dictionary with a dot, and it's now a struct. The reason why it's not complaining is because I think the LSP crashed. So that's on me. I need to fix this. Okay. So you see dictionaries. What I call dictionaries are actually JSON objects. Ziggy is a superset of JSON. So every valid JSON document is a valid Ziggy document. It's just a poorly typed Ziggy document. So I showed you that there's like structs, there's dictionaries, there's also unions. So let's go back to the schema. In the schema, you can see that I'm also defining a union. And unions have this syntax where you basically do a dot. It's kind of like an enum, what can I say? A union also doubles, also can also do enums. In any case, the idea is here, this dictionary is a dictionary of bars. Here it's defined as a dictionary of bars, and bar can have two cases, either cooks with bytes or quicks with ints. And And so you can have both. Here, this right now is complaining about a type mismatch. These two errors that you see here are actually wrong. I have it to do here to fix them. This is actually correct syntax right now that you can see that we have here. In any case, so we have unions. They can also become enums. Like if you give a union case a void value. So here, for example, we can do what is it? Here we can say, I don't know, quacks, and then comma, nothing afterwards. Then you can use quacks this way. Boo quacks, and that's it. And it works. What else? Well, this is the main thing about syntax. I mentioned that we have a schema language. Nice thing about the schema language is that it's kind of limited compared to what you can do with JSON schema. For example, in JSON schema, you can mix static fields with fields that matches regular expression versus fields that are like optional and or like allowing the user to do whatever. In Ziggy, you can't. Abstract has all the fields that exist that have like, it's a limited list of field names. Those have to be there, either that or they have default values. Dictionary is entire the field, all the fields are up to the user and you don't control them through the schema. For example, in Ziggy, as in the document language, so this one, you can create an array of heterogeneous types. Like you can do this. This is complaining now because it doesn't match the schema, but you can definitely write this just like you can in JSON. But this sucks, right? Like if you're doing this for personal consumption, fine. But if you make like a config language that somebody else has to use, like an API, for example, it's like you don't want to have them consume this fucking garbage. So how do you do it? So what does that mean in the context of Ziggy? Well, in the context of Ziggy, it means that there is no way in the Ziggy schema to express this in a nice way. In the Ziggy schema, you can only do this. You can say bar is any. Either bar is any, and then fine, or you say the bar is a slice of something, maybe bool, but then it only accepts bool. It's only okay with true. It doesn't like banana and it doesn't like 10. So you have to make your APIs sane. Of course, you can still say that maybe this is a slice of a union. I don't know. I'm gonna call it, I don't know, my union. And then in my union, you can say that my union has 3 cases. And it has, you know, foo, which is int, bar, which is bool, and buzz, which is bytes. And so in this case, you can do this, foo, bar, and buzz. So you can do this. And this schema mismatch error is the same bug that's happening here. So this is actually correct. But anyway, so you can do this, but you have to wrap them in a union. So there has to be a tag in front of everything that makes this type homogeneous. And that's kind of mostly it, I would say, for the schema language. Last thing about Ziggy in general is that I'm working on a decent tooling for it. So the idea being that really this doesn't want to become big. Interesting. The other ones do get big. This one does not. Well, the idea is that there's a Ziggy CLI tool that gives you out formatting, querying, schema checking, format conversion, language server. And I find it insane that JSON doesn't have this. You know, there's a bunch of different tools that do some of it, but like, why is there like no one good, maybe even official integrated tool chain for everything? And I'm doing this for Ziggy because it seems obvious that we should have this. To be clear, auto formatting, fully implemented, schema checking, fully implemented modulo, that one bug that I need to fix, format conversion. I've implemented JSON, but right now I'm making changes. Everything has been regressed. Language server, definitely works. You saw that in action. That one bug, it was not specific to the LSP. It was just in general the schema validation algorithm that had one bug in it. So this is the story of Ziggy basically. So this is what I'm working on. I think there's one last important thing. Like, I'm really happy with the schema language. It's not complete yet, but I'm really happy with the idea of making the schema language be better than JSON schema. Although, to be fair, that's not a very high bar to surpass. Thank you. What is the $foo at the top? $foo at the top tells you in the schema language, tells you what is the type at the top level type, the root type that you should expect in document. Because while this is another thing that I find annoying with JSON. In JSON, technically, an array or like even a string or even just a number as the 10 is a valid JSON document. But in practice, many JSON serializers and deserializers only support a struct at the top level. This is absolutely not a thing in Ziggy. In Ziggy, anything can be at the top level, and it's expected to be. It's a first class feature. So the point is that, well, then if you want to say that your top level is a list of these guys, how do you do that? You do it here. So here you say, well, my top level type is actually a list of these things, an array of these things. And so this is where you can do this. Other things that I care about that I want to implement in the future is the idea of schema versioning. So some syntax for saying which version this schema is, and also tools that tell you where you can have the tooling take a look at the previous version of a schema and the next version of the new version of a schema, and have the tooling suggest whether there should be a patch, minor, or major version change. Then obviously it's up to you as the user to decide what to do. But at least have the tooling support your decision making and help you avoid mistakes, because maybe you think that, oh, this is just a patch release, but in reality you change something that is more important. Then there needs to be a binary format for Ziggy documents. Then there needs to be the idea of support for templating. So the idea is, you know how people do templated YAML documents? That's not fun. One reason why it's not fun is because it's YAML. One second reason why it's because it's not fun is because it's templated YAML. And the funny thing is that if you think about it, what is the only thing worse than YAML? Templated YAML. That's the only worst thing. So that said, maybe you could argue that the use case of templating config files is a thing. It does exist, and I would argue that it does exist because it has existed. I think it's a legitimate need because this has existed long before YAML was a thing. So what if we had a language where the concept of templating was designed into the language, was part of the language, instead of being something that gets bolted on top? Because the templated YAML, well, not all of them, different implementations do different things, but let's say the general purpose one, the Helm charts, what people do with Helm, that's literally just running Jinja on top of YAML. Well, not exactly Jinja, the Go templating one, which is even worse. So that is disgusting. So that's another thing that I want to tackle. It'll take a while before we get there, but these are the plans for my schema language. Now you know. Can you set it to foo.bar? Good question. No, you currently cannot. That is currently not allowed. More specifically, right now, there is no support for dot syntax that way. The scope, you can nest, but you cannot refer to stuff that is not in your current scope. It's kind of put there on purpose. I do think that eventually allowing dotted paths will make sense, but there will still be some restrictions on how crazy you can get with that. But it's currently not implemented, so for now, no, you can't. Let's see, index corresponding to the node where either a syntax error or a typing mismatch was found. And maybe this needs a format function. So the idea is that if there is diagnostics, then we build an AST. Then we build an AST and we place it in there. And so there is a, now the node where the error has happened. And then you can report that. You can say, this is where things went wrong. That is not a bad solution. To be fair, at that point, you don't even really need the ASD, to be honest. At that point, you only need the boundaries around this node so that you can say, yeah, this is where the error was. Actually, even pointing at the token might not be a bad idea. Well, this is something that I'm not sure what to do about, honestly. I would need to think about more. Seems not a bad approach, roughly speaking, but there's a few different ways in which you can do it, and it's not immediately obvious to me which one is preferable. We could talk in terms of a node index. We could keep around the entire AST. We could just worry about we make the AST, but like as a temporary one. We don't even put it in here, and we just keep in here the node index. We could even make it an option. Even I don't know. to like as in a boolean whether to do this or not instead of having pointers. We could, I don't know, return a union, for example, where you get either the type that you want or the error you get it in the form of no, I think the diagnostics pattern is better, honestly, for that. Would the full AST help? I don't think it would. Because if you, I think having an index, having a span that corresponds to a node, to an AST node, is valuable because that is a good thing. And that way we can know if that node is well formed or if there is an error that corresponds to it. That said, we don't really have to do it this way. Okay, this is a surprisingly interesting problem. This is really a surprisingly interesting problem. Alternatively, we could do something like this. If we find true false, but if we find a int or a float or bytes, and the idea is, well, in this case we return error mismatch, and in this other case we return error syntax. Although, well, this also needs to accept enum, union case, and left square bracket, and is that bracket a single token? .lb. So those would be mismatches. Anything else would be syntax. And maybe there's more syntax errors afterwards. And to be honest, if we do this based on tokens, then we can just return the token information. And there just needs to be some nice printing routine for that. Yeah. So I don't think we need diagnostics. So we accept maybe options by pointer. Maybe we should just um you know what? No, making distinguishing between syntax and mismatch is a bad idea. Let's make something more lightweight than syntax. Let's make it something unexpected. Is it me or SD IO ordering is bit rotted? It should not. It should not be bit rotted. What problems are you encountering? Hmm. It sets an existing fields in the interface create file. This is an non-existing. That surprises me. Create file sounds something like that should be fairly kind of necessary to have, don't you think? Oh, it has been renamed. Oh, their create file. Never mind. I take it back. Maybe it has been rotted after all. So here's what I can tell you, Prasnet, that is information that you might not have that can have a practical impact on your experience. Andrew is traveling right now. He's going to attend in 3 days from now a Zig Day in Japan, and he should come back at some point near the end of the month. So you should not expect this stuff to make a lot of progress until he comes back, but he will when he does. So I don't know. Stay strong in the meantime. Consider fixing this locally for yourself. Or another recommendation would be stick to io.threaded in the meantime, although that one is borked on master branch as well. So here's my recommendation. If you just want to unblock yourself, do this. There's a branch called io threaded no queue. This branch has a big fix to io.threaded. So if you use this branch, in theory, unless I introduce some other delicious bug in the meantime, you should be able to get IO going, no trouble. You will be using the multi-threaded implementation, so it's not going to be like if you're doing benchmark, then it's not going to benchmark the same as the IO ring one, obviously. But that should unblock you in case that you're blocked. And yeah, that's it. And then wait for Andrew to come back. That's the issue I have is that receive message, send message are missing from STDIO. Yeah. Would the PR adding them be welcome? I generally don't know what the answer is to that question. I would say tentatively yes, but then you need to be aware that your PR will be not merged until the end of the month, and then I don't know. Maybe there's an extremely straightforward way of implementing both of them, and then Andrew will be happy with them. Maybe that won't be the case. So I would say yes, a PR would be welcome. Assuming you're aware of, I guess, the usual caveats when it comes to um, sending PRs to Zig. So my point is, if if it's a thing where you spend, I don't know, 30 seconds just to send a PR from a change that you made to unblock yourself, do it. If instead you would be very bummed out if your PR doesn't get merged right away, or just, I don't know, sits there, bit rots a little bit, and then Andrew ends up doing the work himself, and then closes your bit rotten PR. If that would bum you out, then maybe don't do the PR. Okay, I think this is not a bad idea. Return the error location. We don't know what it is. We don't even attempt to distinguish between a type mismatch versus syntax error. We just don't know. We just say we found something unexpected. And then we say, well, then it's on you to get this to show this to the user one way or another. I think this is not bad. Let's remove the part about Ziggy schemas. Okay, I think this is how it should be. Sorry, I've been deep in thought and silent. That's doesn't make for good TV, does it? But such is life. So here's what I'm gonna do. I think I'm gonna call it a day because at this point I want to spend more time just thinking about this stuff. And yeah, so well, the good news is that we got serialization right. I think we now I think have a path, a strategy for getting deserialization right. So once we have serialization and we have deserialization, yeah, we'll be 50% of the way there. The last thing that we need to do at that point, when it comes to the main stuff that we're porting over, is fix dynamic types, dynamic values, and after that, uh, after that, what? After that, well, I don't know. There's definitely going to be more stuff to do. That's for sure. So yeah. Be a good Twitch streamer, man. I'm not a good Twitch streamer, but I can raid somebody. Ethernet cable is live. He seems to be doing Zig. Is he doing Zig? There's only a penis hard flying. Probably something code related, but who knows? Well, stream is tagged Zig though, so hopefully he's not lying. So enjoy some Ethernet cable and enjoy some penis hard thing flying around the screen. See you all next time.